translate for me? Or is it something bad?
Interesting in Japanese.
What is it?
面白い.
No, too fast. I only know one thing. I know two things in Japanese. One of them.
Kai.
No.
Konnichiwa.
Konnichiwa. And the other thing is bad, so I won't say it.
Mm.
Yes. I only know two things. Oh, it's very bad. Very bad.
42. Japan.
Japanese student. So I won't say
Oh,
it.
you have Japanese students.
Ah, yeah. Sometimes we have Japanese students. Usually only maybe one. Yeah.
Maybe one like Mary.
Mary's Japanese, isn't she?
Yeah, just only one.
Yeah, usually only one. Yeah. Okay, did you write this down now? Collisions. Got this?
I never hear about collision. Even the word.
Well, now you can relearn it. Okay, got that? Collisions. You wrote that down? Yeah. Yes? You don't remember the word?
Translate.
No, no, no. What do you think it is?
Something about machine.
No.
About calculation.
No.
No calculation?
But everything is calculation.
No.
Collisions? Yeah. Great.
Not happy.
Collisions. Crash.
Oh.
Yeah. You remember?
Yeah.
Okay.
Oh.
All right. So collisions, like in the picture here. Yeah.
Crash and move together.
Crash and move together. Exactly right. Very good. Yes. And this is a special type of problem in physics. Usually between two forces and between two masses and no extra forces. So what I mean by that is this will crash into this, but there's no extra force. In other words, there's no person pushing it. So it's like the ball just moves here and then this ball moves here and they crash. But there's no one pushing them. They just move by themselves. No extra force. Do you understand? Yeah. So that's what I mean here by no external force.
But isn't this big accelerating force?
At the beginning, but
not afterwards.
Not afterwards, yeah. So for example here, if here's a ball and then here's another ball and this will fall down and hit this one, this is not the problem we will look at because there is a force. What's the force here? The weight, yeah. But if they're on the ground like this and the boy kicks it and so it can move, then is what we look at, because here there's no force. But as you said, there was a force at the start to make it move, but after that, no force. So there's no external force. So at very least, I would like you to note that for these problems, there is no external force. Can you write that down? I mean, you can write the whole sentence if you want. Yes? Grace is fastest today? Congratulations.
When is your holiday finished?
When is my holiday finished?
Yeah. Because someday I go to the library and I see Mark.
Mark? No, he's crazy. I was at home for the whole week. Yeah. You saw Mark in the library?
No.
Oh, you saw him in school?
1 to 2.
Oh, true. Yeah.
And I asked him what about your holiday? And Mark said, yeah, it's gone.
Okay, yeah. No, I decided to stay at home. I thought it was a good idea. Okay, continue. Yes. Okay, so there's a definition here. Um, before we do that, actually, you remember the conservation of energy. That says the energy at the start equals the energy at the end, basically. And you have something similar here called the conservation of momentum. That says the momentum will be conserved. Now, sorry, that's actually, I'm missing something here. Before you write that down, you need to leave a little space if you want. What do I mean by momentum? Momentum, if this has mass and this has velocity, we say the momentum is the mass multiplied by the velocity. And I say that in the definition anyways. I should have really said it before the definition. So anyway, there's a formula. The momentum of the first one plus the momentum of the second one before they crash equals the momentum of the first one plus the momentum of the second one after they crash. Where, well, that's just all the information. Yeah, I don't need to write that part down. Mass 1, mass 2, U1, U2, V1, V2. I didn't say what momentum was. That was very bad of me. Momentum is mass multiplied by velocity. So I really just care about the formula nearly. Oh no, wait, I did tell you what momentum was before, didn't I? Yeah, I was worried. I told you in the Newton lesson. I remember the picture now of the man pushing the mass with the velocity. Yep.
Isn't there like more types of collisions?
Well, yes. We'll get to different types in a moment.
And there are different formulas, right, for each collision? The
Mm,
inelastic collision and the elastic collision.
yes, but for us, this is the only formula we need for collisions. There is another formula called Newton's law of restitution, which we don't use. Okay, you got this? You know what M1, M2, U1, U2, V1, V2 are, right? So you don't need to write that part down. Right, so there's roughly two types of collisions we'll look at. They are elastic collision. Is this what you meant when you said types of collision?
Yeah.
Yeah. So there's elastic. You know what elastic collision?
It moves the part after colliding.
Now that's true, but we actually have a slightly different definition that we use, which I think means the same thing. Elastic collision is when no kinetic energy is converted into other forms of energy. In other words, the kinetic energy stays kinetic energy. It doesn't change. Inelastic, have a guess?
They stay together.
No, have a guess based off of my definition.
It is converted into other forms of energy.
Some kinetic energy is converted into other forms of energy. Yeah? Continue? Well, I think there might be more here. No. Yes? Continue? Okay. So we can have a look at our first example. Okay. Do you know what this is? Trolley? You do? You remember the trolley, don't you? The little car. Okay, so write this question down, please.
This is the model page. Potential energy and kinetic energy tester.
Is it?
Yeah. It's broken down long time ago. And it's a video that dear student, the video of the
Oh yeah,
is broken.
that's right. Now if you go to my YouTube channel,
Ah.
you can get the newer video.
Difficult.
What do you mean? Go to YouTube and then search channel and then type in KEPE.
And search Steven.
Search Stephen's channel, yes. This is a very typical exam question.
Is that it? Is it coming out?
Maybe, maybe not. Because I haven't written the exam yet, I can't I can't say if it's on the exam. So your question is, will I put this on the exam? I don't know.
Which topic do you like best?
Good question. Which topic do I like best?
Please don't, not the reaction force ones.
Oh, you mean like a rocket question or something?
Those
The
yeah.
helicopter question.
The
That's
one
very
with all the
difficult
forces,
question.
the one like, yeah, just don't put that one.
Don't put which one?
The one with like the reaction forces and then like that force plus all the other forces equals the other forces.
All I heard was forces equals other forces. Alright.
No.
No, well hang on. Now, there's my channel.
I have the link, I'll send it to the group chat. Okay.
I thought I emailed you the link as
No,
well.
I have it.
There's me, so you know it's my channel, okay? And then isn't there a search channel here?
Yes, you can make your video, beginnings of your video more like superstars,
With like stars and yeah. Maybe I'll do that next year.
Yeah.
Alright, so
The other teachers videos and I click it, it's like boom 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 or something boom.
okay, maybe. I have my face and then like starring Stephen or something like this. KEPE. There you go, look. It's right there. And there's the picture of the man in the hole, remember? From 1 week ago. This is the one you want, isn't it?
All people watch.
One person watched, yes.
Nice.
That's probably me actually, so look, just search the channel for the latest video.
I sent it to the group already, so you guys can
Okay.
see.
Yeah, anyways. Okay, whoops. Did you write this down?
No.
No. Now the good news is I only have 2 examples to do.
The bad news.
No bad news. Only good
We
news.
have many homework.
Yeah.
Let's see.
Oh my.
Yeah, okay, there's a little bad news.
See you.
Homework is good for you.
No, no, no.
Every time you said
Good for us.
less example and then more homework.
That is good for me and it's good for you.
No.
To write down a good lecture.
No, my heart is become colder.
Your heart is colder. Okay, have we got this?
No.
So it's a 1 kilogram trolley, a 2 kilogram trolley, And the 1 kilogram is moving to the 2 kilograms. Okay. Can I do this now? So what you have, this one is 1 kilogram. This one is 2 kilograms. This one is moving at 3 meters per second. This one is not. Then they stick together. So it's like they are 3 kilograms. And the speed, we don't know. So these ones crash together and then they become this one. Because the question says they crash and then they stick together.
What is STA 下来那个？
Stationary
Yeah.
means not moving. Yes? Yes? Okay. So, the momentum before the collision, m1u1 plus m2u2 equals m1v1. There's just one here. So what does the v equal in this example? What is it? 1 meter per second when you solve this. Yeah, got that? Now what do I ask you in part B? Kinetic energy before the collision. That will be a half mv squared plus a half mv squared, which will be 4.5 joules. I have a feeling my next question is what is the kinetic energy after the collision?
Yeah.
Kinetic energy is a half mv squared, which is 1.5 joules. Yep. So how much kinetic energy was converted or lost? 3 joules was converted. So is it elastic or inelastic?
Inelastic.
Inelastic. Because the kinetic energy before the collision was bigger, or well, in other words, is not equal to the kinetic energy after the collision. Yeah. So, for example, this type of question, you can see it's quite short. So this would be like a section A question, you know, like a 5-mark question, something like this.
All of them.
All of this would be like a short question. Because it's not, it's not much calculation. It's quick to do. Yeah? So this is what I mean by a short question in the exam.
What is the long question would be like? Memo asks.
We haven't done a long question yet. We've only really been doing short questions. Yeah, much English. A long question would be like something we haven't seen yet. Okay. Right, next one. Okay, so write this one down, please. Sorry, that English is bad. It should say a white snooker ball traveling at 2 meters per second, then strikes. Not and strikes, then strikes. Maybe I can fix it. Here, it should say then strikes, okay? Here. Oops. Well, sorry, that's bad English as well. A white snooker ball traveling at 2 meters per second strikes. I don't need and or then. Delete that word. So did you say you had another test today or not?
No.
No. Tomorrow you have maths.
And reading test.
Chemistry?
It's on Wednesday.
Wednesday. Physics Thursday and Friday?
No.
EAP.
Party time.
No, Thursday we have EAP already.
We have EAP.
No test on Friday?
No, I think we do. We have the listening test.
Oh.
Listening test. Would you believe it?
Unbelievable. I really don't like those listening tests. So boring.
And it's
So boring. Don't you think so?
yeah,
Yes.
and it's
Every
like
time.
if you miss like one,
Yeah.
and then you have to like find like where you are now.
No good.
And is this teacher from TUC?
No, people in Manchester make the tape.
But some of video voice sounds like Mark.
Really? I'll tell him this. Yes. They're boring. And it's always some boring
It's
story.
more like an attention
Like
test than a listening test.
student calling someone on the phone.
Yeah.
I am having trouble with my accommodation. Ah, so boring. This is when I'm asked to supervise an exam. This is the only exam I ask not to supervise. I said, reading, writing, no problem, but please don't ask me to do the listening, because then I have to listen too. And oh, so boring. Okay, have you got this? Yeah. Do you know this? Well, I know you two probably know this word, right? Snooker.
Yeah.
Yeah. Do you Trey know this word, snooker? You know snooker. Good. Is it the same in Korean or you know it? No. You know this snooker? It's the game you play with the white ball and then what's it, 12 red balls? And then the white ball you no.
It's yes, I know.
You know,
It's like pool.
it's like pool. You try to get the balls in the hole. You know it. It's actually it's like no, English. It's like this game. Although this game is not called snooker, this game is called pool. Yeah, you know snooker, don't you? Okay, fine, translate.
The idea is same.
The main idea is the same, but the game is actually different. I think in snooker, these are all red in the triangle. Yeah. Anyways,
What is that?
uh, there, snooker.
Oh, oh,
I thought this game was very popular in China.
oh.
No?
No,
I think it is.
no,
It's not there.
no.
It's not in the dictionary.
It's in the dictionary, but I don't know what it is.
You don't know it in Chinese. That's amazing.
No,
You know this game in Chinese?
no. I never see somebody else play this before.
Never
Yeah.
in your life. Amazing.
Wow.
I thought it was popular in China, no?
No.
Alright.
I just different color of ball and some numbers and white ball and
Yes, exactly.
it's not in same color.
Yes. Okay, fine. Fine. You have seen this game before. So the white ball hits the red ball. This is the idea. Okay? So if I just draw it here, whoops. Oh rats. So you have your look, this is can you see that?
No.
Alright, hang on. The white ball hits the red ball. So this one is at rest, and this one's going with 2 meters per second, and it hits the red ball. And then usually what happens when it hits the ball, then the white one stops, and then the red one moves very fast. So my question is, okay. Oh, and I also say in the question that 10% of the kinetic energy is lost as well. Now in part A, I say estimate. So after the collision, this one moves away with V, and we say that this one is about 0. Now if you watch snooker, you know it's not 0, because when the white ball hits the red ball, it kind of moves a little bit, and then the red ball moves very fast. Anyways, anyone know what the V is? You almost don't need to calculate it. Should be about 2, because
But
if this is,
is lost.
yeah, so I mean about 2. So we have M1 U1 plus M2 U2 equals M1 V1 plus M2 V2. So you get V is about, it's about 2. Now it's not exactly 2. Will it be more or less than 2? It'll be less than 2. So
Can you do this? Can you calculate
the kinetic energy.
and then calculate 10%?
Yeah, that's, see, because I think later in the question then I ask you for the exact speed.
But we don't have the math though.
No, but you don't need to know the math. And anyways, yes,
Okay.
I forget what I'm saying. But anyways, roughly the red ball will move at 2, but it won't be 2. If we calculate exactly, it'll be less than 2.
But usually the white ball is bigger than the
No, I thought they were all the same.
smaller. No, I don't think they're the same.
Are you sure?
They are same something.
Really?
Yeah.
I'm nearly certain they're all the same.
Yeah.
Oh, I could be wrong.
I think you are. Now, maybe the white ball is heavier than the red ball, but I thought they were all the same. Anyways, the next part. We want to calculate it exactly. Before and then after. So this one here would be moving, this is M, this one here is M, 2, 0, V1, V2. So now the problem is more difficult when you want to do it this way because you have 2 unknowns. M1 U1 plus M2 U2 equals M1 V1 plus M2 V2. Well, at least what can I do with the M's? At least I can cancel them. So I get V1 plus V2 must equal 2. Now that's no good yet because I need another equation. So what can I use now? the kinetic energy. The kinetic energy here and the kinetic energy here, will they be the same?
Yes. No.
Well, no, yeah, because in the question I said 10% is lost. So what I could say now is that I could do, let me think, K2, kinetic energy after divided by kinetic energy before, that should equal 0.9. If you want to think about it like this. This would mean that 10% was lost. That this one is 10% smaller than this one.
How you can say it is 0.9?
Because, yeah, like it's 90%, 10% was lost, so it means kinetic energy 2 is 90% the value of kinetic energy 1. Yeah? No? Maybe. Okay, maybe. So, kinetic energy before, that's a half mv squared plus a half mv squared, or sorry, u squared. And then kinetic energy afterwards, that's a half v1 squared plus a half v2 squared. That should equal 0.9. Now the good news is I can cancel m. So that's good news. And this is 0, so it's actually gone. Also, I can cancel what? Yep. So I'm left with v1 squared plus v2 squared over 4 equals 0.9. So now I have v1 squared plus v2 squared equals 3.6. Good news. Now I have another equation. Bad news? It's squared.
But
Yep.
because there's only one ball, so but there's two V.
No, there's two balls after the collision. They don't stick together.
Oh, okay.
Yeah. Yeah. Okay, so you know how to do this from maths. What way should we try to solve this?
This is fine, I think.
Well, we're looking for the speed of the red ball. So that's V1 or V2?
V2.
V2. So what I'll do is, I'll get V1 equals 2 minus V2, and I'll put it in here. So I get V1 squared plus 2 minus V1 squared equals 3.6. So I get V1 squared plus 4 minus 4V1 plus V1 squared equals 3.6. V1 squared, nope, 2V1 squared minus 4V1 plus 0.4 equals 0. Is that right? V1 squared, V1 squared, 2V1 squared, minus, yeah. I could divide everything by 2. So I get V1 squared minus 2V1 plus 0.2 equals 0.
Wait, why don't you get the V2 square is 2 minus V1 square again?
From the first one.
Oh, okay.
Yeah. So when you solve this, you get two answers. V1 equals 1.89 meters per second, or V1 equals 0.106 meters per second. So which answer do you think it is? Now this is why I asked you to do the first part. So that in the beginning, here at the very beginning we said V1 is nearly 0 and V2 is about 2. That's actually V2. So which answer do you think is the right answer and which one is the wrong answer?
The right one is the left one.
This is the right one.
No.
Now for V1, the white ball.
Oh, yeah.
Yeah, this one here is the wrong answer. In fact, This one is the answer for V2. Although I don't ask you for it. Yes?
And this is a long question.
It'd be longer. Yeah.
Like rocket science and
Yeah, that's a long question.
question from A to F.
A to F. Yeah, A to F question. Yeah. Okay, maybe not that long. Maybe more like A to E. Maybe D. Maybe. A, B, C, D. Yeah, maybe. If I'm feeling happy.
Are you happy?
I don't know. It's Monday. It's too early to decide. Okay, you got this?
Yeah.
Yep. Right, so now homework time.
Where did
C
you
part.
send?
Oh, sorry, yeah. Well, where did this missing 10% kinetic energy go? Heat between the balls and sound between the balls. Heat and sound, if you want to write down the last part. Heat and sound. Yeah. Physics. Good luck. All of these questions here, some of the, like questions number 1 and 2 will be like short questions. But a question like number 5 would be more like a longer question, because there's more steps to get into the answer. But 1 and 2 would be shorter questions. 1, 2, 3, and 4 are like short questions. 5 would be like a longer question, but not quite a long question, just a longer question.
Longer.
Yes, yes, exactly. All right, we'll finish.